Hey everyone, we are going to continue adding to our table of contents as we add notes. So we did our What is Science notes, so those should be here. And then we did our pseudoscience activity, which you guys actually did online, so we're not gonna really do anything with that anymore because that was supposed to be in class and you're supposed to draw a picture, but we're gonna move on. Our next thing, page 5, is going to be the scientific method. So we're going to write that in on page 5, and then we're going to turn to page 5. So if my table of contents is 1, and I've got that on the bottom here, and this is 2, this is 3, science, what is science? That's 3. The opposite side of that is 4, this one would be 5. We always put our notes on the right hand side, and it's going to be an odd number for our notes every time. So now to start, remember we need to set up our notes. So we're going to draw our lines across here, one there, draw this one here, all the way down. Okay, and then I draw a little one right here. All right, so now I'm going to put up here Mr. Will. And when you guys take these notes, it's going to be Tuesday. What would it be? September 22, 2020. All right, so this is up here. We're going to write scientific method, because that's our topic for today, is the scientific method. Our essential question, the EQ, basically that's our goal for today, is what we're trying to figure out, is what are the steps to the scientific method. I abbreviated it SM because that's a big word. So hopefully you understand that those match up. Okay, so the first note we're going to take for this section is actually the definition of scientific method. The definition is that the scientific method is the steps, or are the steps, used by scientists to correctly test a hypothesis and gather data. So we're going to start by writing our word. Scientific method. Then we underline it, and we put our dash. Now remember, from our last notes, this dash creates an imaginary line. You don't have to make these dots, but I put them there as like a reference. My definition stays on the right-hand side. The vocab word, is only on the left. So this one's a little bit longer, and that's helpful for this imaginary line. Okay, so the scientific method. Steps used by scientists to correctly test a hypothesis and gather data. Now, I noticed some of you were like, oh, I can't read your writing, and I understand. Some of it is harder to read. If you can't understand this, what you could do is actually go back to a point in the video where it just shows the slide and you could copy it off of there. I'm just showing this so that you guys know how I want you to put it in your notes. So this is the definition. So let's go to the Next slide. So the next thing we're going to do is write down the steps to the scientific method. So let's put a big steps. Step 1. So I'm only taking up like 3 or 4 of these lines here. So step 1 is the question. What are you trying to figure out? The next one, number 2, is our hypothesis. Now this is worded a very specific way. So we're going to be practicing this with a couple different experiments. So if I change something, then this will happen. So the key words are if and then. Then we have our effect. And as always, we need to explain why. Why do we think that? We can't just randomly make statements without a reason. Next done, number 3. Now, if you guys need to add a space in here, that's okay. Just make sure you've got your numbers correct. So 3, test your hypothesis. So that's where you actually go through, test this out. So if I change this thing, then it's going to affect this. So I do the experiment where I do change this thing and see, does it affect that thing? Kind of cool. All right, then we go to number 4. Take all that information you got up here on your test and organize it. So organize data. Okay, good. Now let's say you organize it. That's great. Now we have to actually look at it. And that looking at it is called analyzing. So analyze, that's an E, the results. Here's the big question, did it make sense? Because if it doesn't make sense, that means you may have done something wrong. Because it should make sense. I mean, if you understand science, everything should follow a pattern. Once you're done with all that, then we communicate. Your results. So that's just where you're telling people what you did. And that's where other scientists would test out your experiment to verify it, make sure that it's right. And maybe you're doing the same thing, you're verifying someone else's experiment. So those are the 6 steps of the scientific method. It is important that all of your tests are repeatable so that other people can do your experiment as well. Okay, so 2 more things that we're going to add to this one page, and then we'll be done with notes for this page. So there are 2 very different things, but a lot of people interchange them, which is unfortunate, but we're going to talk about the difference. So the scientific law versus a scientific theory. So let's start with scientific law. So let's write down the definition. Scientific, oh, I spelled it wrong. Scientific law. Got ahead of myself. Now this one, I'm gonna put our underline. Now I've got my imaginary line here because I made a dash. Okay. So a scientific law is a rule. That's kind of the important word there. Also, I guess the describes part, but it's a rule. So a rule and a law, those are the things you should really kind of connect together. So the rule that is describing, rule that describes, underline that, a pattern. Oh man, it's sloppier, sorry. Oh, now I don't go over here. I'm gonna write it right underneath. Observed, repeatedly in nature. So it's not trying to explain why. It's just saying, hey, this is what happens. And we've got some really great examples, so I want you to write at least one of these down. So gravity is a great one. Uh, it's just saying, this is what happens. So if I drop my pen, it falls at this speed every time we're on Earth, I should say. So it's a pattern. It happens every single time. If there's one single time that it doesn't happen, it is no longer a law. So that's yeah, it's a pretty big deal. Um, so let's just stick with gravity. That's a great example. I need to move it up more just in case. We'll do that. Okay. So now the next one is a scientific theory. Now, a lot of people in like detective shows, they're like, I have a theory. Not quite the same as a scientific theory, because a scientific theory is actually a hypothesis over years of testing. So anyway, let's do the definition. So I have my imaginary line, remember, after my dash. So a scientific theory is an attempt to explain why a pattern is observed repeatedly. So we still have these patterns, but the main difference is this explain why. So a theory is like, I think this is why it's happening, whereas a scientific law is like, this is what literally is happening. So it's a rule. It happens every time. Theory is like, this is what we think is causing this pattern to happen. So it's kind of cool. There's a bunch of examples for this one as well. So there's like the Big Bang Theory. I'm sure you guys have seen the show. Big Bang Theory. It's just explaining the um, formation of the universe, which is kind of cool. There's evolution, and there's also the theory of relativity. That's a big thing for Einstein. So there's some good examples. So this is actually it for this page. That's all we're going to cover for today. But I would like you to have it written out this way. So if we look back at it, maybe from a little higher, can I move this up a little? So we notice that these vocab words really pop out. And even these steps, like they're kind of segmented away from everything else. So this is well organized and it'll be a lot easier to study from when we lay it out this way. So again, this is on page 5. Hopefully you did that beforehand. And yeah, these are our notes for today.